wave function so frequently that it cannot doesn't have time to unitarily evolve to any of the other states, because any evolution that would start slowly rotating somewhere would be immediately kicked back. That's why Sino effect.
Yeah.
I mean, I think
yeah. I mean, that would mean that just one piece will caught, right?
No, because
there's also the other effect of like a stochastic transmission just between the motional states without any coherent.
Yes, so the point is, so in that quantum Zeno regime, the interaction Hamiltonian is basically now effectively zero, and each system just equilibrates with its own thermal bath. Okay, and for the motion, that thermal bath is infinite temperature, so it will just keep heating up. So once you have too much dissipation, basically each system just sees a thermal bath, it doesn't see anything else.
That's the virtual temperature, basically.
Exactly, yeah.
Okay.
So, and then you had a couple of other questions. So, yeah, about the entropy. I mean, I think. Well.
Yeah, you're quite right. So you said they're more interested in mean energy than entropy.
I think that's true. It would certainly be interesting to think about what the number. I mean, we could certainly calculate the number fluctuation, and it's. I mean, it's certainly in addition to say, look, this is not just reduction of energy, but also reduction in number fluctuation. Somehow I feel intuitively that it's not actually possible to just reduce the mean phonon number without reducing the fluctuations.
But one is a bound on the other anyway. If we know the mean energy, the worst case that could be is that it is in a Gibbs state, which we believe it is anyway, because that maximizes the entropy for that given energy. So you always have the right kind of bound, knowing the energy.
Oh, that's true.
You mean the worst state possible with that energy.
Yeah. So I think that is not so much. So I think what would really be interesting is the coherence in the subspace, which is probably extremely difficult to access. But maybe we can keep thinking about if there is anything like any sort of witnessing scheme that, because if you were able to get that coherent off-diagonal part, you would be able to talk about entanglement, coherence, and
also
the heat flow.
Yeah.
So that would be awesome,
but that might be quite hard.
But are they so interested in these things? Are they interested in this, like,
look, I mean, if you find entanglement, the paper, you can write a much sexier title.
Well,
I don't think it's actually
I
relevant.
wouldn't put entanglement in the title in any case. But I mean, you might.
No, not for us. I'm saying if an experimentalist does an experiment, and then he finds a microscopical heat engine or an entangled microscopical heat engine.
What are they going to choose? Yeah, for sure. No, that's true. And